Hi, and welcome to this new tutorial in our little series about sound synthesis. Today we're going to talk about slots and how you can use slots in a bach.roll and bach.score to control parameters of sound synthesis. So you probably already know something about slots. Let's just review the basic fundamentals. Slots are containers of generic data that are attached to notes in back.roll and back.score. To open one of those containers, I can just select the note and hit the number key on my keyboard. Then you have more slots than number keys, but that's another thing, and we're not going into that. But for the first thing, let's just type 1. Okay, so I'm selecting the note and I hit 1 and I have this. You will get something slightly different actually because you won't read filter cutoff frequency and you won't have this breakpoint function drawn here, but we'll get to there very quickly. So when I hit 1, I open this window, and this window is the graphical representation of the data that are attached to this node. And I don't have just slot 1, I also have 2, 3, 4, and so on up to 30. Okay, so the first 10 slots can be opened through the 10 number keys, and the remaining 20 can be opened in other ways that we're not going to discuss, but it's all very thoroughly documented. For example, in this little synthesis patch I have built here, I have a filter, a low res tilde, a low pass resonant filter, and I want to control its cutoff frequency dynamically during the course of each note. So, for example, what I'm doing here is that I have this note that is a middle C, and I have this red line, which you're not seeing yet in your own back.roll if you're trying to build the same patch, but we'll get there. So we have this red line, and this red line represents how the filter cutoff frequency varies over the duration of the note. So how do I do this? I have to take care of two sides, so to speak. One is the back.roll side. So I need to set up my back.roll so that the note actually contains this shape, and the shape has some specific parameters attached to it. And the other is the patch side. So I will need some objects and some modules to retrieve the profile of this BPF function and use it to control the frequency of low res tilde. Let's see the back.roll side step by step. First thing, I open the slot. Now key 1. You're not going to see this as I was saying, but we're getting there immediately by hitting Command I if I'm on a Mac or Control Alt I if I'm on Windows. And I get this window, okay, the slot info. It might be, if you're not in full screen, that you don't see all this information, but you can just scroll up and down. And now let's set some parameters from this slot. Now, what does slot info mean? Each node will have a slot 1, a slot 2, a slot 3, and so on, up to slot 30. The slot 1 for each node will contain different data, but those data will be placed in similarly shaped containers, so to speak. So here I'm defining the properties of the slot 1 container, and these properties will be the same for each first slot for each note in the score. It's like saying I have 20 boxes, they're all the same color, they're all the same shape, they're all built of the same material, and they all contain different things. So here I'm defining the properties of the box. Now, first thing, I want to set a name. So just double click and you can enter filter cutoff frequency, which is just a symbolic name. Okay. The type is going to be function. So I want an actual BPF function to be drawn in the slot window. We don't care about the hotkey. We leave the color as it is, and so on and so on and so on. Now the range. The range is very important because it's a cutoff frequency for a filter. It's going to be from 100 to 10,000 hertz. You can enter whatever you want here, but this sounded like a sensible choice to me. The range slope Now, this is more like a graphical thing, but the range slope is an interesting parameter because we probably don't want our y-axis in the function window to be linear. We actually want more resolution towards the low end of the frequency range. Range slope is a quick and dirty parameter helping us with this. And as we will see in the different examples that we will see today, we will have different figures for the range slopes, which frankly I've found more by trial and error. And what I can tell you is that when it comes to frequencies in this kind of context, I usually use 0.65. Okay, I leave all these unchanged, and then I click kept in background. And this is what will allow me to see the BPF drawn in the main back.score window, the display, the score display of back.roll. Now let's close the slot info inspector after setting these parameters. And let's go back here. Now my advice is make sure of having a point at the beginning of the function and the point at the end of the function. To add the point, you can just click. And if you want to delete a point, you can command click on a Mac or control click on Windows. And you can also add a slope to each of these segments, and you do this with control on a Mac and control shift click on Windows. Okay, so this is what we can do. I can just click outside the slot little pop-up here and see what I've drawn in the back.roll main display. If you don't see this, it's probably because you forgot to check the kept in background option in the slot info window. Now the question is, what happens when a note with the slot is played back? You might wonder, is back.roll going to play somehow this curve over time? And the answer is no. Back.roll will just output the whole contents of the function, so its whole definition, all at once at the beginning of the note. So we need a way to get this information and convert it to an actual time function happening during the note playback. And we do this with this combination of back.slot to curve and curve tilde. Okay, now this is a very handy combination. It is so handy that at some point we might even consider putting everything into a single object, and we're actually discussing this, but it's not going to be something happening anytime soon. What does backslot to curve need for working? It needs the duration of the note and the contents of the slot. So let's go back to back.play keys, which we've already seen over the past tutorials in this series. Now, what do I need to retrieve from back.play keys? The sense, as usual, because I want the note to be pitched. The duration for back.slot to curve. Okay, that's what goes in the first inlet of back.slot to curve. The contents of the first slot. I can get this by simply adding a 1 as one of my keys in back.play keys. And as you can see, duration and the contents of the first slot in whatever format is output from back.roll are just entered in the first two inlets of back.slot to curve. And that might be it, but just for convenience, I get the duration one more time. There is nothing preventing me from having the same key typed multiple times over a single back.play keys, and we're going to do this even in the next examples. I just get the duration one further time for what we used to call the technical envelope, okay? So the one that we use for preventing clicks. Now, there are a couple more remarks we have to do. Now, back.slot to curve produces an output which is meant to enter curve tilde. For some reason I'm not even very sure of, we decided in the beginning that backslot to curve was meant to return an LLL, a native format LLL. So I'm kind of forced to add at out M here, because otherwise curve tilde would not understand the native format of the LLL. And now curve tilde actually produces my curve in time. Let me just do this. Let's add a live.scope tilde object and set it to a reasonable range which I can do here. So the range might be, for example, from 0 to 12,000. Okay, so that we have some leeway. And let's hook it to curve. Okay, like this. Now it's high because I'm coming from a previous playback and I'm here, okay, virtually. And let's play the score and see what happens. And please try to follow what happens here and compare it with this function we've drawn. And as you will see, the two will look very much alike, except for the fact that the y-axis of live scope is linear, whereas the y-axis of the function here has been defined with a nonlinear representation through the y-slope parameter. So let's go. I think it makes sense. Let's play it again. This kind of structure is one you will use all the time. Whenever you want to connect a time varying parameter to a slot, you will typically want to use the combination of bach.slot to curve and curve tilde, or in some cases, bach.slot to line tilde. Or even, as we're not going to see today, but I'll keep this for a more advanced tutorial further on, you might also want to use backslot to line connected to line without tilde. That might be handy for some specific cases. Let's now move to the second example. This example is not going to add very much to your previous knowledge, but it's a more complex one, which might be handy just to review the concept and putting everything together. So what I'm doing here is that I want to control two parameters of my synthesis process. As you can see, they're displayed with a red and a blue line. And I also want to have a pitch and velocity envelope. Of course, I can combine everything. Let's have a look at the synthesis process first. I have a pink noise that I filter through a resonant filter. The pitch of the note is actually the cutoff frequency of the resonant filter. I want to control the Q of the resonant filter. This will be the red line, that is lot 1. As you can see, I have added colors to my patch cords here just to make it a bit clear. So the red slot goes here, and it controls both the Q of the resonant filter and the gain of the resonant filter through a like rule of thumb formula, which is just take the Q, calculate the square root of it, and you will have a reasonable choice of a gain for keeping the sound level more or less consistent. So that's a handy trick I use all the time whenever I do synthesis with narrowband filtered noise. Then I want to add a distortion module. That's the overdrive tilde thing here. And I want to control the amount of distortion through slot 2. So here you go. You see blue line, blue chords. Plus, I also want to control the pitch and velocity curve. And for this, I'm basically applying the same technique we've seen over the latest tutorial. Plus, I have my technical envelope. So I've colored coded my chords here. I don't think there is so much to add except maybe having a look to the slot info. So I'm opening the slot info for slot 1. Once again, I hit 1 and then Command I or Control Alt I if I'm on Windows. I change the name, I change the range, which goes from 1 to 10,000. And here I wanted to have much more resolution than before over the y-axis. So I raised a little bit the range slope. It's 0.75 now. And it's kept in background. Now I hit 2 and I go to the slot info for slot 2. As you can see, the name is distortion. It's always a function. And the range is from 1 to 100. And the range slope is 0.65. It's also kept in background. Then I can, as you can see, by hitting 1 and 2, move from one slot to another, add, if you'd like, points to the function. Let's, I don't know, change the Q a little bit. That's it. Remember to set the attributes to back.roll that allow me to work this way with velocity and the glissando line, the breakpoints. Okay, and now I can play it. Okay, So I think that's pretty clear. We hear the Q raising, so actually the bandwidth of the filter is decreasing. We hear the distortion raising, and then we hear the pitch and overall dynamics changing. Okay, nice. Now you might wonder, do slots only represent function varying over time, over the duration of the note? And the answer is no. We're going to see this in our third example. This is a more complicated example, which kind of paves the way to the discussion of polyphony that we will start with the next tutorial in this series. What I have here is an additive synthesis process, which is based upon the new multi-channel object of Max that have been introduced with Max 8. The sound I'm going to produce is a harmonic one, so I'm actually going to add together sinusoid in harmonic ratios, whose fundamental is this one. And what I'm doing with my slots here is that I'm controlling the amplitude of the 8 partials of the 8 harmonics I'm going to produce, the attack time of each harmonic, and the decay time of each harmonic. And these attack and decay times are relative to the duration of the note. So let's have a look at the slot info first. Command I or Control Alt I if I'm on Windows. So the name of the first slot is amplitude, and the type is not function anymore, but it's float list. So this allows me to add this kind of bar representation of a list of floating point numbers. I'm expressing amplitudes in decibels here. So the range is minus 90 to 0. And the range slope in this case is minus 0.4 because I actually want to have more resolution near 0. So the upper end of my range rather than around the lower end of my range. And I'm not keeping it in background because if I kept it in background, I would only see a list of numbers and I don't find that very much fun. So once again, the very important parameters here are float list, range, and range slope. Let's see the second slot. The second slot controls the attack time, and remember, I want to express the attack time relative to the duration of the note. So it's going to be a number from 0 to 1, where attack time 0.5 means that the attack time is exactly one half of the duration of the note. And I'm setting a range slope of 0.5 because generally speaking, I want more precision for small attack times than for big attack times. I care about the difference between 10 and 20 milliseconds, and I don't care about the difference between 910 and 920 milliseconds. So I really want more resolution towards the lower end of the range. Then I have a decay time. It's a simplistic envelope, of course, it's just an AD envelope. So I have the decay time, and the decay time has basically all the same settings except for the color. I just left the default and, of course, the name. So these are my 3 slots. Okay, and of course you can toy with them. I wanted to work with a different pitch range here, so I changed the clef because it's actually going to be a nicer and more interesting sound in the low register. And now let's have a look at the patch, which is a rather complicated one. Let's consider one piece at a time. Now let's start from frequency. Here I get descents, which are then rendered into a sense curve here through the bach.dl2 curve module, of course, and the fact that we are taking into account the whole pitch curve here through this chord, okay, so through the breakpoints output. Now this is MIDI sense, this is MIDI pitch, and this is frequency. And here is where things get interesting because here I get a set of channels, each containing one harmonically related frequency. So if I had 100 here, I get 100, 200, 300, and so on until 800 in 8 separate channels in this signal chord here. This goes into MC cycle tilde, which actually produces 8 sine tones at harmonically related frequencies. And this is where the frequency part somehow ends. From now on, we have sine tones. Each of these sine tones, as you can see, is multiplied by its amplitude. So let's have a look at what we get here. Now, the interesting thing is that if we ask, as we have done for the max format, the float list is just a plain list. So I can enter it into dB2A. I just want to pad it with zeros in case I inserted less than 8 partials. I'm using bach.pad 80, which means if the list is composed of less than 8 elements, then add zeros until you get an 8 element list. And I prepend the apply values message, which will be accepted by mc.times tilde. So here I just applied a static amplitude value, which is independent for each partial. Now I want to apply to each of these voices its individual envelope. This means that I want to multiply each channel by a time varying envelope, which is independent for each channel, of course. Now, what do I get from here, and from here? Well, what I get is a list of attack time, a list of decay times, and the overall duration of each note. This requires a bit of formatting for mc.curve tilde. I have three ways to do this. Let's have a look at the first one. Remember, relative attack time, relative decay time, duration. This is a list, this is a list, this is a scalar. So what I'm doing here is that I'm iterating over these two lists in parallel so that at each iteration step I get one value for the attack and one value for the decay. I'm multiplying those values by the duration. I'm formatting them so that I can get a list of the form that is accepted by curve tilde. So one, that is the destination level. $1, that is going to be the attack time, this one. 0.6, this is a nice slope I like to have for this kind of scenarios. And then I have the decay part. So 0, because I want to get to 0, the decay time, and minus 0.6. And I'm sending this to mc.target, which will take the place of each pair of element in the original list as the voice index, and will return messages for the curve tilde object. I have two much more compact ways to do it that take advantage of the bach.eval object in increasingly complex and compact ways. I would say we're not going to discuss them, but you can find them in the patch and have a look at them if you'd like. So let's take this thing, so the message is as formatted for mc.curve tilde, and inject them into a further mc.times tilde, which will impose the individual envelopes to the various partials of my synthesized sound. And then, eventually, we add the overall envelope to the sound, which is the one I've drawn here. So as you can see, it's an envelope that stays loud for all this portion of the note duration and then goes back to virtual silence, that is minus 60 dB, in this final segment of the duration. Now, this is the easiest part because it's basically what we've done so far. Curve tilde, scale tilde, dB2A tilde is the usual thing. I'm multiplying a multi-channel signal by a single channel signal. That's totally allowed. Then I'm reducing everything to stereo. And then eventually I'm adding my so-called technical envelope. Now here I'm seeing a small stupid mistake. That's very stupid. I don't want DAC tilde. I want mc.DAC tilde. Okay, so let's do it now. Let's play it. Now here is where synthesis starts getting interesting to me. Let's play it again. So that's all for today. Next time we're going to start discussing real polyphony. Bye bye.